Okay. 83 from the derivative multiple choice says f of x. That's the square root thing. I thought square root later was this problem, and I got ahead of myself. F of x equals 1 over x squared plus 1. That one, right? G of x equals, okay, I'm going to carry it again. It's not going well this morning. G of x equals the square root of x. And we want to find the derivative of f of g of x. All right. First off, this is a composition of functions, right? F of g of x. So there are two ways to go about doing this problem. The first way is, there's one way, it's the chain rule, but you can sort of do it in two different ways. One thing that you can do is you can just say, well, the derivative of a composition of functions is f prime of g of x times g prime of x. So if you just know that chain rule formula for a composition of functions, you can do that. So the derivative of f of x, what's the derivative of this? Of f prime. We can use the reciprocal rule for that function, right? So that should become negative 1 over that squared times the derivative of that denominator, the numerator, so negative 2x over x squared plus 1 squared. And then what's g prime of x? It'd be 1 over 2 root x. So we really just need to evaluate this, replace all the x's with g of x, f prime of g of x, and then multiply it by g prime. So if I replace all of the x's up there with root x's, I get negative 2 root x over root x squared, which is x, so x plus 1 squared. And then we're going to multiply that by this 1 over 2 root x. And then the 2 root x's should cancel, and we should end up with negative 1 over x plus 1 squared, which hopefully is an answer choice. Is that an answer choice? Choice B, right? They've written it as negative x plus 1 to the negative 2. But which seems counted. Why would they write it like that? I have no clue. So you could do it that way. The other way that you could do it, if you wanted to. Everybody good with that? There, you good with that? Yeah. Everybody in the Zoom good with that? Good. Wonderful. The other thing that we could do is we could say that we had f was 1 over x squared plus 1, right? And g was just root x. So we could find f of g of x first, which would be what? 1 over x plus 1. Looks like this way is going to work out a lot easier, right? And then we just need to find the derivative of that, which is the reciprocal rule again. So that's negative derivative of x plus 1, which is 1 over x plus 1 squared. That's what we got. So sometimes the other way works out more easily. Sometimes this way works out more easily. In this case, this way worked out a lot more easily because it simplified those functions down quite a bit. But either way is good. Anybody have questions on that one? No? Everyone's good? Okay. Great. Other questions from the derivatives multiple choice? Sarah, what? 86. Okay. Number 86. 86. This looks like it's an inverse rule one, yeah? They give us f of 1 is 2. They give us f prime of 1 is 3. They give us f prime of 2 is 4. And they say, what is f inverse prime of 2? All right, inverse rule says if f and its inverse, if f has an inverse, f inverse, then if we're looking for the derivative of f inverse f2, that's telling us that f inverse contains a point 2 comma something, which means that f must contain a point 1. Something comma 2. Right? And once I figure out what this value is, we can set up the inverse rule for derivatives. So first, let's figure out what that is. F of what equals 2? F of 1 equals 2, right? So this is a 1. So now the rule says that f inverse prime of 2 should equal one over f prime at 1. And f prime at 1 is 3. So this should be 1/3. That's just the inverse. Good? Inverse rule, an important rule. There's almost always. What?
The f prime of 2 was just extra information that we didn't need.
100% correct. Yes, that f prime of 2 is just there to screw with you. It's there, and they put an answer choice of 1/4 in the answers, I'm sure, to make you think that maybe you should have used f prime of 2 instead of f prime of 1. Show that there an answer choice of 1/4. Good. Everybody good with that one? Great. Other questions? Sarah? 91? 91. Yeah. 91 is stupid. I remember doing these during the other quarter. They're not going to ask you anything like this. But that's fine. What are they saying? They're saying they're giving you this thing that they're calling the symmetric difference quotient, which is not something you need to know about. So they've written out that this thing f prime of some value is not a thing that's part of the AP test. I don't know why they. And then they say for f of x, what is the estimate? F of x is mod to the x. The estimate for f prime of 2 h equals to 0.03. Yeah. All right. So we want to find f prime of 2. So all that's telling us is what they want you to do is they just want you to plug in a value of 2 in for x up here, and then a value of 0.03 in for h. So they're saying what is 5, f of x of 5 to the 2 plus 0.03 minus 5 to the 2 minus 0.03 over 0.06. They're just having you plug in h and then plugging in that x value of 2x, not as 2. But this is not something they will ask you to do on the AP test, 100% positive. Never seen something regarding these symmetric difference quotients. So you just approximate that on your calculator, because this isn't the calculator section. I don't know what it comes out to be. What does that say? Anybody have a calculator? Know what that comes out to be? Anybody with a calculator know what that is? Sarah? Just so we know what that is. I don't have to just look at the answers. But. Probably like 40, one of the 40s, my guess is. Just on my rudimentary knowledge of logarithms and what the value of the natural log of 5 is. But I couldn't tell you which. 40.252? Yeah. Doesn't have to be 40.25. Does that make sense, Sarah? Other questions? Sarah, no? That's it? Anybody else? What? That's it? Yeah. Zoom people, other questions from the derivatives multiple choice? Zoom people? Zoom people? Are you even there?
Yes.
Do you have any questions from the derivatives multiple choice?
Not off the top of my head.
Okay. They shouldn't be off the top of your head. You should have made a list of them over the last week when I told you to do them. That's okay. We've done a lot. Everyone's good then? No more questions on derivatives multiple choice. I know we were supposed to do anti-differentiation multiple choice today. We'll see if we can get to that. I'm gonna push back the shell stuff that I was planning on doing because it's not required for the AP test. So if we don't like the chance of you needing it is 0. The chance of it being helpful is like 5% chance that it might be helpful. So I want to do it before the test, but it's not like imperative. So let's move forward and finish up our regular volume stuff. That way you guys have tonight and tomorrow to really work through all of the extra. Did I put up the extra problems on volume yet or no? Not yet. Yeah. So I'll put those up after class today, like between first and second period. So I want to give you guys today and tomorrow to work through those before we have a quiz on them on Friday. None of them will require you to use cells on the quiz, but there might be some on that homework. Probably helpful, but anyway, we'll work on that later. So we're gonna do a couple more basic volume type problems, except instead of revolving around the x-axis or the y-axis, we're gonna do a couple where we revolve around something like, we did that one with x equals 4. We're gonna do some more like that. Sound good? Everyone feel okay about that? Zoom people. Oh, there's a thing in the chat. Oh, yeah, I can do 90. We're gonna do number 99. We got some question. Right, 99. How many points of discontinuity does f prime have? It must be. There's a graph early. All right, we're gonna look at this graph. Graph looks like this, and that's from -6 to 7. Let's see. Okay, blah, 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 blah. Okay, and then what does it say here? It says, how many points of discontinuity does f prime have on the interval? So was this graph f or was this graph f? This graph f. Okay, this is f of x. So we're looking for when does f prime have a discontinuity? That'd be when does the derivative of this not exist, right? So f prime does not exist. A derivative doesn't exist at 4 different places, right? There's a vertical asymptote, right? A discontinuity, right? A corner, a cusp, or corner, cusp, discontinuity. There's 4. What's the fourth one?
Vertical asymptote?
Yeah, but that's a discontinuity. Did I include those as 2 separate things when I talked about them? No, vertical tangent line. That's what it is. There we go. Vertical tangent line, corner, cusp, and discontinuity. I don't know why I forgot that for a second. So 4 options for why a derivative might not exist. There are no vertical there are no discontinuities in this graph. So if this had a discontinuity, that would tell us that f prime was discontinuous, or didn't exist at a point. There are no vertical tangent lines here, right? Because there's no places where it's like curving like this. That'd be a vertical tangent line. So none of those. There are no cusps because there are no curves. So the only thing that we might have that would cause the derivative not to exist is a corner. So we just need to count up how many corners we have. We have 1, 2, 3, 4, 5 corners. That's 5 places where that derivative doesn't exist. Does that make sense? Yes. Wonderful. All right. Anybody else? Any other questions from the derivative? Yeah. Sure. You don't need to ask. You just tell me you're going. That's fine. Say, I'll be back or something. I don't know. Everyone's good? Zoom good? Zoom good? Good Zoom?
Good Zoom.
Zoom good, good Zoom. Okay. All right. Zoom's still good. Right? Chat Zoom. Okay. This is the thing we decided during second period yesterday that I have to talk like this. It saves me lots of time. Right? Zoom good. Good Zoom. No chat Zoom. Math now. We decided because remember when that guy was walking around the other day? You guys remember when the guy was walking around? He was just walking around. No.
I don't remember that.
You do remember that?
I don't. I wasn't there.
Well, you weren't here. How would you remember? All right. Let's see here. Let's do a problem. Let's do a volume problem. A revolution. You got a line you want to revolve around? Yeah. Well, lines are straight by definition. So yeah.
Like a horizontal.
Sure, a horizontal line. That sounds good. Y equals 2. Okay. All right. So we're gonna take the region between sine x and how about let's call it sine x and x squared. And x squared in the first quadrant. Okay. There's only one region between them, right? And we're going to take that and we're going to revolve it around the line y equals 2. That's going to be our plan. So the region between sine x and x squared, and we're going to go around y equals 2. Sound good to everybody? We want to find the volume of that irregularly shaped solid. Because who knows, maybe we needed to like 3D print it and know how much material we needed or something. Because it was like an important piece of like our death robot that we were creating for like whatever they do with the death robots over there in the engineering. Don't they do death robots or something? Yeah, I think they do. Okay, so how are we going to do that? Thoughts? I'm going to take this and go around y equals 2. I'm revolving around an axis that is horizontal, just like the x-axis, right? True? And when we go around the x-axis, or around any horizontal axis, which way do we need to slice it to get discs or washers? Perpendicular to that axis, right? We have to slice it vertically. And if we slice it vertically, we should get a washer. We should get a circle with a circle cut out of it. And we're just going to use that exact same formula, but now we've shifted away from the x-axis. So finding the radii is going to be slightly more complicated. So if we think about the outer radius should be the function that is furthest away from the line y equals 2. Right? Not necessarily not necessarily the upper function. Right? The upper function is closer to y equals 2. The lower function is further from y equals 2. So the one further away from the line you're revolving around is going to give you the larger radius. Everybody here good with that? Everybody in the Zoom good with that?
Good.
All right. So the radius, the outer radius, goes from here down to my function. That is not very well drawn. So we're going to try that again. I'm going to do it over here. To my function. Yes? That lower function. That lower function is x squared, right? What is the total distance in the y direction? Because the y direction is how I get that radius, isn't it? The total distance from the x-axis to y equals 2 is 2, no matter what, right? Well, what's the distance that I need to cut off from 2 to get the outer radius, which is the distance between y equals 2 and that function? It's x squared, right? It's very small here in my picture, right? This little distance right here that I'm doing in green there, that's y equals x squared. That distance is x squared. How far over x that I've gone? x squared, and that's how high up I've gone. And so that's how much I need to knock off from 2 to get that outer radius. Does that make sense to everybody? Sophie, okay with that? You're blankly staring at, I don't even know what. Okay. All right, so our outer radius is 2 minus x squared. What about our inner radius? You okay, Riley? You're good? Okay, all right, make sure. What about our... I want custom color. Now I have one. Okay, what's our inner radius going to be? Our inner radius should be the distance from y equals 2 to the upper function, the one that's closer to it. Okay, well, which function is closer to it? Sine x, right? So this is our little bar. And what's the height of sine x at any x value? It's sine x, and that's what we need to knock off from 2 to get that inner radius. So our inner radius is 2 minus sine. Does that make sense to everybody in Zoom and here? I know the picture is awful, huh? Yeah, the picture is awful. Here's what we're going to do. This will be fun. Maybe this will help. There's y equals 2. There's my x-axis. There's my y-axis. Right. The outer radius is the distance from 2 to x squared. The inner radius is the distance from 2 to sine. Good? Does that help to have it a little bigger to visualize it? No, it was good before. Okay. Yeah, that helps? All right, good, okay. All right. So if our outer radius is 2 minus x squared and our inner radius is 2 minus sine x, all we need to do then is do outer radius squared minus inner radius squared, multiply by pi, and integrate from 0 to wherever these intersect, right? So we'll say pi integral 0, 2 minus our outer radius x squared, right? 2 minus x squared, squared minus 2 minus sine x squared dx. And then we got to figure out where these two things intersect, right? True? Okay. So we need to know, when does x squared equal sine x? Well, we know one place, right, is x equals 0. Our graphing calculator ought to tell us the other point. So you should get out your graphing calculator. Have we done how to find a point of intersection of two graphs on your graphing calculator? I don't think we did that. Did we ever? No. Okay. So those of you at home in the Zoom, you need to get out your graphing calculator. We're going to learn how to do this real quick. I'll give everybody a second to get out their graphing calculator. It's very important because if you don't know how to do this, you're going to have some difficulty on the calculator section of the AP test. So make sure you get your graphing calculator. Oh, I'm trying to get yours. Okay, you guys are not going to share. You're not going to get too close, but you're gonna look on from afar. Yeah. Okay. Wonderful. Great. All right. So what you need to do to figure out where x squared and sine x intersect is just go into y equals and graph both of them first, and just graph x squared, graph sine x. And when you graph sine x, make sure that your calculator is set to radians. You got your calculator? Can you look on from afar at Ryan's? Yeah. Oh, wonderful. Okay, so you're gonna graph the two. Wait, is Austin? You got your you got a calculator. You guys got that. Yeah. Everybody at home, get your graphing calculators, right? You want graphing x squared and sine x? Okay, very easy to do this. You're going to hit second. Then you're going to hit the calculate button. It's one of those 5 buttons across the top. Where it's like, I think it says, I think the button says something different. But yeah, it says second. You're going to hit second trace, which gives you the calculate button. And then there's an option in that window that says intersect. Not intercept, but intersect. Right? You want the one that says intersect. Not intersect. The intercept one will find you in x-intercept. The intersect one will tell you where these two things intersect. All right, so when you hit intersect, it should just take you back to the graph. Everybody in the Zoom back in the graph. You hit second, trace, intersect. You guys good there? Okay. All right. It should say left bound. Is that true? And then a question mark? Yeah? First curve question mark. Okay. It says first curve question mark. All right. So what you're going to do is you can see on your graph where they intersect. I mean, you can see it, right? You can see the intersection point that's not 0. When it says first curve question mark, make sure you are to the left of that intersection point. Okay. Doesn't have to be right next to it on the left. It just has to be somewhere to the left of it. Hit enter. It will switch your cursor to the other graph and say second curve. Does it say second curve? Yeah. Then you're going to use the little arrow buttons on your calculator to scroll to the right of that intersection point. Once you have scrolled to the right of the intersection point on the second curve, you're going to hit enter again. And then it probably says something like guess question mark. Does it guess question mark? Yeah. Once it says guess question mark, hit enter again. And then it will give you an x value at which these two things intersect. What did you get for the intersect? 876 what? What?
7.
Another
Oh,
7?
sorry. No.
8767
262.
262. Now, very important point. I'm going to stare at you in the Zoom as I start saying this. Very important point. When you use your graphing calculator to approximate something, use the full number that your calculator gives you throughout the entire problem until you get to the end. And then at the end, you may round to 3 decimals. 3 decimals. Always 3 or more, it's fine. But don't do that till the end. So we got this intersection point. We're going to put 0.8767262. And then you will evaluate that integral on your calculator like we know how, math 9. Type it all in, get a number. Anybody at home have an issue getting that intersection point?
Not with getting the intersection point, but only one of my equations is being graphed when I enter them both in.
Okay. Okay. 1 second.
I can send you a picture.
Yeah, you can send me a picture in Remind. That's fine. I'm
Okay.
gonna tell you how to. Don't send a picture send a picture of your y equals 3, not of the graph itself.
Okay. And I'll stay after class too.
Okay. I mean, you can if you wish.
Okay.
I can answer it during class. I got my phone. So.
Okay. Give me 1 sec.
All right, I'll look at it when it comes up. Do you guys all get that? You guys all here got the intersection point okay? Yeah? They told you guys are okay? Okay. What did you guys get as the value for the integral? Anybody? Yeah, so, our radii are 2 minus x squared and 2 minus 5. The difference between the two functions. Who's sending me a remind message? Did you
I
send
am
it?
sorry. I haven't sent it yet.
I am.
Ian.
Ian. All right, Ian. You haven't sent it yet. Okay. All right. Anybody get a value for the integral? Anybody? Anybody? You can round to 3 decimals. Still typing it in. Oh, fun. The reminder came up on my phone to pay the cell phone bill. Great. Should make the school do that since I have to use my phone for work now. Bet they won't do it. Did anybody get a value for that integral? 1.426, that sounds like something other people got? That seems reasonable. Anybody, 1.426? Or did you get something different? Riley, what did you get? You didn't do it. Oh, you're just sitting there. You should do it. Yeah. You got 1.426? 1.426? It's okay to say the numbers that you got. It's okay to say those numbers. All right. 1.426. I don't have the calculator in front of me, so. Did you send that thing in or no?
I'm sending it now.
Okay. All right, I just got it. Okay, most likely your issue, I think, scroll up to the top of your calculator in the y equals screen. See how you have plot 1 is highlighted there?
Yeah.
Yeah, just hit enter on plot 1. It should unhighlight it and then hit graph again, and then it should. If it doesn't,
No, it still just shows sin x. And then when I go back to the y menu, the equal sign for x squared is unselected.
okay, then go select it.
No, but I had selected it originally. And then I press graph again. And then when I go back to y again, it's unselected.
Okay, so you have plot 1 off now,
Yes.
and then the equal sign is highlighted on the sin x.
Yeah. And sin x shows up, but not x squared.
And x squared, you have the equal sign highlighted or not highlighted?
It's not highlighted, but when I highlight it and press graph, it's not there still. X squared is not there. And then when I go back to y equals, it's unselected again.
Okay, unselect both of them. Both of the equal signs.
Then nothing shows up.
Nothing shows up.
Yeah.
And if you reselect them both and you hit graph, only sin x shows up, and then the x squared one becomes unhighlighted.
Yes.
Okay. Do you have anything saved on your graphing calculator that you care about, like formulas and stuff?
No.
No. Okay. Here's what you're gonna do.
And this is the TI-84 Plus from school, if that makes a difference.
It doesn't, but thank you. All right. You're going to hit. You're going to hit. Okay, there it is. Second, and then the plus sign.
Okay.
And then you're going to go to option 7.
And then
Wipe it down with. Yeah, now that I'm touched the light also. And then it should just restart your entire calculator.
it brings me to a menu of RAM, archive, and all.
Yeah, just RAM.
All RAM.
Yeah.
Okay.
That should do it. And then, yeah, it's second plus 712, I think is what you got to hit. That's the number in my head. Then a 1, then a 2. Then it should reset it, and then go in and try and regraph them and see if they both show.
Okay, I'm trying it right now. There we go.
Perfect. Yeah, I'm not sure what the
Thank
issue is, but we reset everything on your calculator. So make sure that you're in radians again, because I think when you reset it, I think it defaults to radians, but just make sure.
Yeah, it is. Thank you.
No problem. All right, everybody good with this now? And you'll have to, I mean, you'll be a little behind here because you just didn't get to do all this, but you'll do it with the next one. Everybody good there? Everyone's good. No issues. Everybody in the Zoom is good?
I'm not getting that answer again. I'm getting 0.2794, like when I keep like adding parentheses and making sure everything's separate.
You can send me a picture of what you type in, and I can figure out what's wrong with it. Yeah.
Okay.
Negative 1.14? 11. That's not bad. Oh, yeah, you don't even need that. If that's not what you want. You did it. 1.462, 426. Wonderful, you did it. You didn't just sit there.
I did it.
That's good. That's good. That's good news. That's an improvement from when you were just sitting there. All right, everyone's good now? Oh yeah, somebody is sending me their thing. Did you send me? Who was just telling me they were going to send me something?
Yeah, I'm gonna send it. I'm just taking a picture.
Okay. All right. We're going to sort of start moving towards the next one, but I'll troubleshoot your thing as soon as the picture comes in. All right. We're going to just real quickly, we're going to use the same two functions. So we're going to use sine x and we're going to use x squared again. And let's talk about what if we wanted to revolve that around the line y equals 5. How would that change the formula that we were using before? Right. Our outer radius, instead of being 2 minus x squared, right, would be 5 minus x squared. And our inner radius, instead of being 2 minus sine x, would be 5 minus sine x. Doesn't really change it much at all, but I mean, it changes it, but not a ton, right? You all agree with that? So we could put this, you know, be the same intersection point. We could put this integral in and do it that way. Everybody feel okay about that? If I said revolve around y equals 4, it'd be 4 minus x squared and 4 minus sine x. If I said revolve around y equals 100, it'd be 100 minus x squared and 100 minus sine x. Everybody good there? Yes? Yes. What if I said take it and revolve it around this line, y equals -1? That's going to change things a little bit more significantly. So take a second and see if you can come up with the two radii for this, the outer and the inner, while I solve Matthew's issue here. Let's see here. 2 minus x squared. You didn't square your 2 minus x squared.
I couldn't show it all in the. I didn't know how to get it all in the picture together without taking like 10 pictures. But I did square it after, and then I did minus, which you can't see that part either.
Okay, I can't see it. I can't see it. So 2 minus x squared. Okay, so here's what I'm reading. Let me see if I can. This is what you should have written based on what I see. Parenthesis, and then you have another parenthesis, 2 minus, and then you have parenthesis x squared parenthesis. Then you should have another parenthesis and then a squared, which I can't see. Do you have that?
Yeah, I do have that. So you're saying 2 parentheses before the 2 at the very beginning, right?
So I'm based on. Okay, I'm just gonna write it up inside on the screen here. So everybody else ignore what I'm writing here for a second. This is what I see in yours inside your integral. I see parenthesis, 2 minus parenthesis x squared. And then I see nothing, and then I see the other picture. So I assume what you have there is parenthesis squared.
Yeah.
Minus parenthesis. And then I can see this is the opening parenthesis for your 2 minus sine x. But you have it written with a squared right there. You need to close that parenthesis and then put a square. Close the parenthesis for the 2 minus sine x first, and then that squared needs to be that side. And then you have a last parenthesis. Didn't look good. You have another parenthesis outside of that squared to close the entire expression. So that should fix it for you.
Okay, let me try this.
Got birds there with you, Matthew?
Yeah, I'm typing it in. Let's see.
Was the yes to my question about are there birds there with you?
What was that?
It sounds like you have birds. Do you have birds?
Yeah, there are some loud birds outside my window.
Ah, that's what. You can hear the chirping birds of spring. How wonderful. DM, I just saw your question, so I'll answer your question in a second. Once I solve Matthew's problem here. Did that work better now?
I accidentally added a second exponent, which I couldn't get rid of, so I had to restart again.
All right. Okay, so real quick, let's do this y equals -1. Let me know if that works out. What did you guys get for your outer radius if we did y equals -1?
1 plus sine x.
It should be, yeah. So now our upper function is the one that's furthest away from here. This distance right here is 1 unit. And then we have to add in another sine x. So our outer radius should be 1 plus sine x. And then our inner radius ought to be 1 and then this x squared. So inner radius ought to be 1 plus x squared. Everybody good with that? Question? Or which one? The 2 minus x squared and the 2 minus sine x? I think it was 1.4 something. I can look at your calculator in a second.
And Mr. Bachelor, I got negative 1.911. I'm in radians. I'm really confused.
Okay. Okay, here's what you're gonna do. This is how you're gonna write it out. All right, everybody good with the 1 plus sine x and the 1 plus x squared? Okay. All right, Matthew, you're gonna write exactly this into your calculator.
Okay.
Pi, integral, I don't remember what the 0 and whatever that limit was, I don't know what it was. You're gonna then type, parentheses, 2 minus x squared, you don't need to put the x squared into parentheses, squared, minus, parentheses, 2 minus sine x, and you put that as in parentheses, squared, dx. Then a parenthesis outside that square to close the whole thing. And then your dx goes outside that parenthesis. That should get you the right answer. If that doesn't get you the right answer, then I don't know. You'll have to.
There we go.
That work? All right. Perfect. Okay.
Thank you.
No problem. All right. Everyone's good with that? 1 plus sine x, 1 plus x squared? Okay. All right. DM, I haven't forgot about your question. I'll get to it in a half second. What if I ask you to go around the line y equals -100? Your outer radius would be 100 plus sine x. Your inner radius would be 100 plus x squared. Everybody good with that? Okay. So I feel like we should be okay with revolving something around any horizontal line. You've just got to figure out what the difference between your function and that line is. So usually, the difference between your function and the x-axis, either plus that number or that number minus your function to get that difference between, depending on if the line is above or below the region that you're looking at. Good? Everyone good there? Okay. All right. Dan, I'm going to go back to the one you were asking. What do you do after you hit second trace intersect, right?
Yeah.
Yeah. Okay. So it should say first curve on your calculator, correct?
Yeah.
Yeah. So make sure that when it says first curve, you are to the left of the intersection and hit enter. Then it should say second curve. Use the arrow buttons to scroll to the right of the point of intersection and hit enter again. then it should say, what?
Yeah.
Then it should say guess and then hit enter again.
It's a dash?
What?
Wait, what am I supposed to do after that?
After what?
You said press enter on the right side of the intersection.
Yes. And then it should say guess and then just push enter again. And it should get the value at which they intersect.
Oh, okay.
Cool.
Okay, thank
No problem. All right. Let's, I'm going to give you guys one to do here on your own. Make sure you guys can set up the full integral and then evaluate. So we're going to take the region between, how about, let's take the region between the square root 4 minus x squared and how about and x plus 2. We're going to take that region and we're going to revolve it. I want you to do two things. I want you to take that region and revolve it around y equals 3, and I want you to revolve it around y equals -1. So try to set up integrals to represent taking the region between y equals x plus 2 and y equals the square root of 4 minus x squared. I'm talking this specific region right here, not the other part that's bounded by the x-axis as well, just this one, and revolve that around y equals 3 and y equals -1. So set up integrals for that, and then try to, and then evaluate them. Actually, yeah, don't bother evaluating. You can't.
Without calculator.
What?
With or without calculator.
The evaluation of them, you would have to do with the calculator. You should be able to, I mean, you shouldn't need a calculator to set it up because the intersection points should be nice on there. You will definitely need a calculator to evaluate, unless you know how to do inverse trig substitutions for integrals, which you probably don't.
So would our upper limit for the function just be the y-intercept? Because if we were to do like the point of intersection, it would include the little bit of the first quadrant.
That's just my bad drawing skills. It goes through -2, 0, and 0, 2, both of them. That answer your question. My line just was a little bit too low. Yeah. No, there's nothing in the first one. No, just this section in red.
You said evaluate or don't evaluate?
You can if you want. Mostly I just want to know that you guys can set it up properly. Some people had trouble evaluating, so if you had trouble evaluating, it might be good to do it. How are we doing, people here in class? Doing okay setting it up? People at home, you doing okay setting it up?
Yeah.
All right. Let's talk about y equals 3. So if we're doing y equals 3, we should get an integral from where to where? -2 to 0. Right? Pi out in front. Our outer radius, since y equals 3 is up above that region, the outer radius comes from the lower function, right? So the lower function is x plus 2, so it should be 3 minus x plus 2 squared. So you can simplify that down if you wanted to, just to make it 1 minus x, that'd be fine. And then we should subtract from that the inner radius squared, and our inner radius ought to be 3 minus the upper function, so 3 minus square root of 4 minus x squared. Everybody good with that setup? Anybody evaluate it? 13.141. Anybody else evaluate it and get that same thing? What do you mean, what do we do with it? Right. We just did y equals 3. We're about to do what if we revolved it around y equals -1. Somebody else get 13.141? You didn't evaluate? Anybody evaluate? You got that? Same value? Perfect. 2 people. That sounds like I'm certain that it's right. Okay. What about around y equals -1 then? We should end up with pi times an integral from -2 to 0. Now our outer radius comes from the upper function, the semicircular equation. So that should be 1 plus root 4 minus x squared. And then minus, again, 1 plus x plus 2 squared. And what that one come out to be? We did. 3 minus square root of 4 minus x squared. The radius, the outer radius is going from here to here. The inner radius is going from here to here. Anybody get a value on that last one there? 15.55. Give me at least 3 decimals. 15.550. I'll take it. Anybody agree with that? 15.550? Seems about right.
Yeah.
Cool. We got the idea? Kind of got the hang of it, hopefully. All right. Now, what if I say, take the region between the square root of 4 minus x squared and try really hard not to confuse people and make sure that this goes. There we go. Okay. Take that same region, but let's revolve it around the line x equals -3. Okay? So this is still x plus 2, but we're going to go around x equals -3. So this is going to be a little bit more difficult. Maybe. We'll see. If we're going to go around a vertical line, what do we need to do in terms of slicing? Which way do we need to slice it to get washers?
Horizontally.
Horizontally, right? And if we're going to slice it horizontally, that means that we have to do everything in terms of y. So this is going to become pi times an integral. And then in terms of y, what's the lowest part of this region? 0. And what is the largest part of this region? 2. So we're going to do pi times the integral from 0 to a bunch of stuff, dy. Right? We got to figure out an outer radius and an inner radius. So what is our outer radius? Our outer radius goes from this value of 3, or -3, sorry, all the way over here to this point. Right? It goes from there to there. Right? What's the entire distance from here to here? 3. How much do I cut off? I cut off some x amount, right? Some x value happens to be a negative x value. Okay? So the outer radius ought to be 3 minus x. But this x is the x from here, right? And if I need to put that in terms of y, what does x equal? X equals to y minus 2. So this is 3 minus y minus 2. Everybody good with that? Zoom, are you good with that? Which would be 5 minus y. What about the inner radius? The inner radius goes from here to the other function, doesn't it? Should be 3 minus some other x value. True? But that x value comes from y equals the square root of 4 minus x squared. So what is that x value? This radius is 3 minus the other x. This x is 4 minus x squared equals y squared. Okay? And then we can make that x squared equals 4 minus y squared, x equals the square root of 4 minus y. So this will be 3 minus square root 4 minus y squared. Everybody got that? We got to flip it around and turn it into terms of y. Good or no? Zoom, are you good with that or no?
Yeah.
Okay, so minus, and then it was a 3 minus root 4 minus y squared dy. And anybody evaluate that in their calculator?
$8.592.
Anybody else agree with that? 8.592? Or no?
I did something wrong. Hold on.
Okay. Hopefully you didn't get 8.5 on tape, but then you did something wrong. 88.5? What? 88? 88? 5.3, what? Okay. Cool. All right. Good or no? Any issues with that? Let's do one more. Let's do some different functions this time. Let's do, run out of time. Okay, let's do, how about let's do 4 minus x squared. The region between 4 minus x squared and y equals x, and then the x-axis. So let's talk about this region right here. 4 minus x squared, the x-axis, and y equals x. And let's revolve that around the line x equals pi. And see if we can set up an integral for that. You're going to have to either use the quadratic formula or completing the square to figure out where those intersect, or your calculator. That'd be fine too. Just quickly using the quadratic formula, that's where they intersect. If you want to use that value, or you can have your calculator approximate that for you. What's your outer radius?
Five minus y.
5 minus the x value that we get from the linear piece, right? This is 5. This is x. This is 5 minus, we'll call this x1. 5 minus x1. That x1 is just 1. So 5 minus 1. And our inner radius ought to equal 5 minus, so 5, right? But minus this x. And that x is, that's this x, right? That's that equal to y. And what do we get? We get the square root of 4 minus y. Our inner radius is 5 minus root 4 minus y. Everybody good with that in Zoom?
Yeah.
Everybody here good with that? So 5 minus y squared minus 5 minus root 4 minus y squared dy. And then somebody approximate that, and then we'll be done for the day. And then we will be done with everything that is required for the AP test. Yes, Austin. 37.694. Anybody else agree with that? I like to have two people in agreement at least. Yeah. Great. Anybody have any questions on this? No. Oh. I screwed that up, didn't I? I screwed that up. That's the wrong intersection point. This is the x value of my intersection point, and I need the y value of my intersection point. True? So that answer is wrong. Oh, it's the same value. Perfect. Lucky. I didn't screw that up. This y equals x. It's the same value. Woo! Lucky. Yeah, it should have been the y value. For some reason, I spaced on that as I was going through. That should be the y value, which is the same as this x value, because they are on the line y equals x. Good news. So yeah. Thanks for pointing that out. That's good. Yeah. So make sure you do use the y value, not the x value. We'll even write y. Zero. Lowest to highest. Good? Okay. So